Hello everyone. The next measurable property of an aquifer is specific retention. And it is indicated by the symbol SR. Look here. These are the rocks. In between the rocks there will be small soil particles, and in between these soil particles there will be space, and that space is called as what? Voids. When the rainfall happens, the water starts to infiltrate to these voids, and some amount of water gets retained in a space and some amount of water gets down. You can just say infiltrates, or it just passes, okay, or it gets seeped, okay, or you can just say it gets drained. So what I will be doing is I will take the volume of the water which is retained in this void spaces to the total volume of this formation, then that ratio will give me the specific retention. Clear? So specific retention is what? The ratio of volume of water retained to the total volume of this formation. So this is the one more measurable property of an aquifer. Okay. Let's go to the next measurable property of an aquifer. The next measurable property of an aquifer is storativity, or is also called as storage coefficient. Okay, and that is indicated by the symbol ST. Okay, storage coefficient or storativity. Look here. Here we have two cases. Okay, the first case is for confined aquifer, and the second case is for unconfined aquifer. Okay, I will write a schematic diagram to explain about storativity or storage coefficient for a confined aquifer and for the unconfined aquifer. Look here. In a simple way, we will write a diagram, a schematic diagram. look here. This is a schematic representation of a confined aquifer. As you all remember, confined aquifer is an aquifer which has got bottom impermeable surface and upper impermeable surface. Let's name them. And just call it as layer or surface. Okay, and this is the schematic representation of an unconfined aquifer. Unconfined aquifer will be having bottom impermeable layer, okay, and it won't be having any impermeable layer above it. It will be having the water table, okay. What is this? Unconfined aquifer, okay. Clear? I hope I made it clear about the confined aquifer and unconfined aquifer, okay. What we'll be doing is we will insert a piezometric like tube inside an aquifer. Let me say confined aquifer. What happens? The water starts to rise inside this piezometric like structure tube and it will stop at some particular point, right? Okay. Now I have written a dotted line here, okay. It represents a piezometric surface. Now what do I mean by a piezometric surface? A piezometric surface or a piezometric line is an imaginary line if this impermeable layer is not there and if the water body is standing freely, it forms a layer or a surface. That surface is called as what? Piezometric surface, okay. So let me come back to the previous explanation. What happens once you insert this piezometric like surface or tube inside this aquifer, the water starts to rise inside that, okay. If I am extracting the water from this confined aquifer, if the water is available in this confined aquifer, the water will come out. What happens? The level of this surface gets down, okay. Let me say there is unit drop of the piezometric surface, okay. That's what here it is indicated, okay. Let us say there is a unit drop of piezometric surface. Let me say there is a drop of 1 meter of piezometric water level and that is indicated in the diagram, okay. And let's say this surface of this tube is of unit A. Clear about it? What we did? We took a confined aquifer, we inserted a piezometric like structure. What happens? Immediately the water starts to rise and it will stop at a particular point, okay. And if I start to further extract this water, water will come out. What happens? There will be drop of this surface. Let's say there is a unit drop of the surface, okay. And this piezometric like structure will be having unit cross-sectional area. Now you can define storativity or storage coefficient as the volume of water which is extracted per unit drop of the piezometric surface per unit cross-sectional area is called as storage coefficient or storativity. Okay, and this is for confined aquifer. Similarly, we have an unconfined aquifer here. Here also the piezometric light tube will be having unit cross-sectional area. What happens once you insert here? There is readily water available, water comes out, and this water table gets down. Let's say it has gone down of an extent of unit quantity. Okay, let's say unit drop down. Okay, what happens if you just keep on extracting the water starts to get lowered in this piezometric like structure. We are just measuring it for a unit drop down. Okay, so if I say storativity or storage coefficient for an unconfined aquifer, it is defined as the volume of the water which is extracted per unit drop down of the water table per unit cross-sectional area. Here I am using the term water table. In the case of unconfined aquifer, I will be using piezometric surface in case of confined aquifer, because confined aquifer will not be having free water table. We will take the reference of what? Piezometric surface. This has been asked for 5 marks. You should write these two diagrams and you should write the definitions. Clear? Okay. The next concept is the permeability for an isotropic and anisotropic soils. Okay, as you all know, the definition of permeability is what? The capacity of an aquifer to readily yield the water when you are going to dig the borewell or when you start to extract the water. So let's know about the isotropic soil and anisotropic soil. Okay, if you measure the property of the soil in different directions, if the properties of the soil will not be same in all those directions, then it is called as anisotropic soil. And if the properties of the soil remain same in different directions, such type of soils are called as isotropic soil. The different types of properties are many. We will take a property, one property, that is permeability. It is there in your syllabus, the permeability of an isotropic soil and anisotropic soil. So the permeability for an isotropic soil will be same in all the direction. It will not vary if you just calculate or if you measure the permeability. Okay. The anisotropic soil will be having the permeability value to be different, and isotropic soils or any kind of soils are formed when there is a process of sedimentation. Because of the weathering action, what happens? The properties of the soil or the permeability of the soil keeps on changing in different direction. That is, it will vary in the horizontal direction and it will also vary in the vertical direction. Because of the process of sedimentation, the soil will be formed in a different layer like this. Okay. If you want to calculate the permeability of an anisotropic soil, let's say, what I will be doing is I will be collecting the soil sample in this first layer, and I will be testing it for the permeability value, and I will be calculating it in the horizontal direction as well as I will be calculating it in the vertical direction. Let's say KH1, KV1, and if I calculate the permeability in the second layer, it will be KH2 and KV2. Similarly, you can calculate up to the bottom layer of the soil. Okay, like this. Okay, and there is a formula to calculate the average permeability of this anisotropic soil in the horizontal direction and in the vertical direction. The derivation of that is not there in your syllabus. You should just remember the formulas. I am going to just write the formulas for it. We should first represent the soil layers schematically. Okay, you should represent the coefficient, the permeability values in the horizontal direction and in the vertical direction in the different layers like this, having the different depths D1, D2, D3 and D4, and the total depth of the soil layer is D. Okay, now if you want to calculate the average permeability in the horizontal direction or in the x direction, you are going to calculate it as these formula is used to calculate the permeability in the horizontal direction of this entire soil. Okay, in the vertical direction we have a formula. So this is the two formulas you have to remember. There is no derivation for this. They will just ask to write a note about the permeability of an isotropic soil and anisotropic soil. Specifically, they will ask permeability of an isotropic soil. You should represent it with the help of this diagram, and you should write these two formulas, and you should write the notations. Well, KV1, KV2, KV3, KV4 is what? The coefficients, not coefficients, the permeabilities of the anisotropic soil in the vertical direction. Similarly, KH1, KH2, KH3, KH4 are what? Permeability of an anisotropic soil in the horizontal direction. Okay, and these D1, D2, D3, D4 are what? The depths of the soil layer. Okay, this is about the permeability of isotropic and anisotropic soil layer. With this, we have completed the properties of the soil which can be measured.